WordLadder is a game, so you are going to have starting word and goal, ending word. So for example, boiled and Cooper. Then you are going to move on to the next word. Only one letter will be changed. So boiled, I can change it to boiled first. Then I can change it to the cooled. Then I can change it to cook. And finally, Cooper. So there's a total of 5 steps, including starting and ending. So 1, 2, 3, 4, 5. So it looks like a path length. The number of steps represents a path length. Then lines to mold it. For one example, it can have like 18 steps. That means we are going to use a given word set to work on this. We are going to offer 2 word sets. One of the words set to play this game is words.txt. It's on our AI website. We use the AI website all the time, and we still keep it. So you can go there, then you can look at what other stuffs are there. Then another word set is word 6 longer. So if you download those 2 files, you can see words.txt has a total about 5,000 words. So last one is 4,969. That is the line number there. That means around 5,000 words are stored in the words.txt. And words 6 long is still holding only 6 letter long words, but now this one has about over 20,000 words. So when you get a sample or shellcode on the bottom, you can see different result. Depends on which word set you use. If you use a word set, just a regular words.txt, when you start from listen and ends at beaker, you need 9 steps. But when you use words 6 longer, when you start from same word, end with the same word, now it takes 7 steps because listen will have more adjacent words. It has more choice. If I come back to the note, in the back page, second page, it shows one sample. Let's just see if this is better. So when I start from the word nailed, you'll have sailed, sailed, mailed, wailed, railed, and tailed. 6 adjacent words. And for example, railed will have 1, 2, 3, 4, 5, 6, 7 adjacent words. So various steps. Step 1 is you need to find all the adjacent words in the word set. The very first thing we can do is word set is a set which has all the words. So we are going to use the thing, if we made already a word, then if we want to check if this word is in word set, big O efficiency for this one is just big O1 because it is set. Finding an item, searching an item in the set is always big O1. We are going to remember this, then use this to make our code faster. Let's think about some strategies. We have nailed. I can think about how many words are in AILED as a second through the ending word. in the word set. You can also think about how many words ahead, except the second one, everything is the same. How many words ahead, except third one, everything is the same. Then fourth one is wild. Then fifth one is wild. Finally, the last one is the wild. So how many words has this shape? You can think about that way too. And in the word set has 5,000 words. If you want to check how many words has this shape, you're going to take big O 5,000. So basically, if you want to check each word, it's big O n. So for each one, if it takes 5,000, then I have 6 cases, it will be 6 times 5,000. It doesn't count. Then 30,000 search. This is now really good, so we are going to think a different way. We are going to use ego efficiency. To use this one, we are going to make the word first. So to the wild card, except N, I'm going to use another 25 alphabet. Just fill in with A, so A-A-I-L-E-D. Then check if this word, like A-A-I-L-E-D, is in word set or not. That means just finding this one is a big O 1. So 25 times with the big O 1 will be big O 25 for each case. In that way, 6 times big O 25, so total 150 searches needed. How about the old way, the blue way? If my word set has 20,000 words, like word 6 longer, the total search becomes 20,000 times 6, so 120,000. If my word set has like 2 million, 12 million. But if I use 25 alphabet, then use set search in set is always big O 1. So big O is always 150, no matter what size word set I have. So you need to remember that do not go through word set. Never use for loop for the word set. No. You're going to just check if what pre-made word is in word set or not. That's one strategy you have to remember. It makes your code very fast. So you are going to finish generate adjacent method first. That's the step 1. Then second step is, now this time we are going to use bi-directional search to work on this. Bi-directional search is much faster than BFS because each time you are going to explore from the start and from the goal until you meet, until you have intersection, like something like this. So it's half of the exponential, the half of the power. When the regular BFS is this power for the time complexity, bi-directional BFS has d to the d over 2. When the branch factor is like, look at here, it's so big. So if a branch factor is 10, then depth was 10. 10 to the 10th power versus 10 to the 5th power. Whole bunch different, like a billion versus just 100,000. So we're going to work on bidirectional BFS. Let's think about how to write the code. First, I probably need to check while frontier has. But this one has two directions to check expand. So I'm gonna have like a for the frontier or the check frontier. It may start from the start, then backward frontier. It may start from goal. Then while goal has something, I'm going to keep expanding. It's like a regular BFS. I'm going to pop from the frontier for the frontier. It's BFS, so I'm going to just pop 0. Then I'm going to check the goal. Then if I do not meet the goal, I'm going to go through all the actions. That means to generate children, generate adjacent. Then the rest of them is the same as I did in the BFS. Only one thing different is goal test. Instead of comparing with the goal, I'm going to check if my state is in backward frontier or not. So if one of them is S or not. And at the same time, I need to search it from the backward too. So in the same while loop, now I'm going to hop from backward frontier. Then I'm going to goal test. That means basically I'm going to check if my state is in for the frontier or not. Then if it's not meeting the goal test, I'm going to just say for actions. That means generate adjacent and do the same thing as I did in the BFS. If you do this one, you are going to see you can find the goal much faster than regular BFS. So you can also compare with your regular BFS to do this. Then you will see that.